Hello viewers and my dear students, welcome to session 2 on thermal analysis. I'll be showing you a demo on simple 1D heat conduction problem, typically known as furnace wall problems. Okay, this as you know in the last session, I've shown you how to do this. In the last session, I've shown you how to do it by theoretical means. See here, this okay. This I have shown you by theoretical means. That means this is this has a thickness of 0.135 meters. This has 0.075. This is 0.115. That is 13.5 centimeters, 7.5 centimeters, 11.5 centimeters. I converted into meters. In that way, I put here. This has a thermal conductivity of 1.2, 0.14, and 0.85. Okay, all low thermal conductivity. Okay, it's almost like insulators. That is why so much heat is being generated here. By the time it should come here by some circulation, we should see that it should be around 40 degrees. Here it is 40 degrees. Here it is 870 degrees. I have given the details here. That is fire brick, insulating brick, red brick with all thermal conductivities and all that I given. And here that heat flow rate, okay, heat flow rate or heat loss to the surrounding is 10,593.3 watts you get. Thermal flux, the heat flow rate per unit area is Q divided by 10, that is this. That means in Ansys directly you get this, and depending on the area you just multiply. Okay, that is why you are getting this. That means you have to try to get this 1059.33 and the interface temperature. Here this is T1, T2, T3, T4. T1, T4 you know. T2 is 750.82. T3 is 183.3. That has to be proved. Okay, this we'll do it now using Ansys. Okay, now you see here, as I told you earlier, you do this. First you do clear start new. Okay. And just do fit. Okay. Now, once you do this, file, change job name you do. By default, it will be in the file. Now, if I do this, just now if I do this, I have created one log file Gurdat furnace problem. That means whatever you do now, as I told you earlier, it is graphic user interface. There is one more method of doing this by log file operation. That means in the Gurdat furnace problem, that is when you list log file, no, log file would have created here. Okay, there the log file, that is the program for this would have been created, that you can copy and paste and you can get you can execute the answers and all that. I'll come to that in the next sessions and all that. Okay, see here, once you have done this, then file, change title also. Change title, it is basic problem. That is furnace wall problem. It's a this is a basic 1D heat conduction problem. No, everyone is supposed to know. Okay, in that way, this cannot be left out. This basic thing you should know. I've already done theoretical calculations and all that. Please go through that once. Okay, once if you go through that, you can easily manage this. Okay, now what I'm showing you only is how to do by Ansys. Preferences, structural, thermal, you preferences, thermal you take and say okay. Okay, then preprocessor, element type, add, edit, delete, you press, add. In the menu, what you get now, thermal solid you take, you can take quad 4 node 55 or 8 node 77 also. Okay, here you'll have only 4 nodes, you'll have 8 nodes. This will be more accurate, but at least for the present problems and all that, you can get more or less better answers here also. Okay, for this, you can use this plain 55, quad 4 node 55 you take, just say okay. Okay, now once you're done this, you just say close. Okay, then you see here, don't apply real constants can be fed, but you don't have to worry. You even only for three-dimensional aspects and all that, only to get the thickness and all that you can feed. You can feed or you need not feed also. Here only you had an options, no? Here you can play with the thickness you could have given. But since you directly get that Q, that is heat transfer rate per unit area, we are not bothered about that. Okay, we will not go for the 3D and all that. You are getting the same answer except for the 3D view. Everything remains same. That is why I'm not giving any thickness, sir. Okay. Now, once you do this, material properties you go. Material properties in regular structural analysis was you are getting Young's modulus, Poisson's ratio. No. In the same way, here you do this. Thermal conductivity is one very good property. Okay. This conductivity, isotropic, first one you see here, first one has a thermal conductivity of 1.2. 1.2 you say okay. Then material, new model you take, next okay you say, then again isotropic you do, second material has a thermal conductivity of 0.14. Okay, you feed this. Then material, new model, okay, isotropic, okay. The third has a thermal conductivity of 0.85. Okay, these things you feed this. This is thermal conductivities and all that. You please check. It should be proper. Otherwise, you are not getting the answers properly. Once you do this you do. Okay, once you do that, you store it. This and the material models, no? You have material 1, material number 2, material number 3 and all that. You can even check also. Okay, 1.2 I have fit. 0.14 I have fit. 0.85 I have fit. I think it's okay. Okay, that is material exit you do. Okay, we have fit the properties correctly. Then you come to the modeling. Modeling part you come. Okay, create areas you create by two corners you create. Now the first area is 0.135. That is 13.5 centimeters. Height you take it as 1. Okay, 0.1351. Height you can take anything. You take it as 1. Okay, height is 1 because finally we are interested in Q by A only. Heat conducted per unit area. Okay, in that way 0.135 height is 1 you take. Just say okay. Okay, now you get. Then work plane, offset work plane to key points. You push this coordinate system to this. Okay, your x is here, y is here now. Again by two corners. Okay, now next is 0.075. Okay, 7.5. Height is 1 only you take. Okay, then you say okay. This has come, this is another area what has been created. Then the same way, work plane, offset work plane to key points, you push it to this now. Now it has pushed to this. Rectangle by two corners you do. The third rectangle is 11.5 centimeters or 0.115. Okay, 0.115 you take width, height 1 only you take. Okay, in that way, you create one. Then once you do this, this work plane, no, this you push the offset work plane to origin of active coordinate system. You push it to this. Now you have been created three areas. Okay, three areas. One is 0.135 into 1, another is 0.075 into 1, another is 0.115 into 1. In that way, three areas have been created. Okay, then I'll tell you the meshing procedures and everything in the next session. That is session 3. We'll try to complete the problem by meshing, giving the boundary conditions, everything. Okay. Thank you, friends. Thanks for watching. We'll continue this in session 3.